Yes, hello everyone. In the previous class, like we have completed the angle modulation, especially frequency modulation and the phase modulation. Now we were going to proceed with receiver. But before that, let us do some numerical on the frequency modulation so that it can become more clear to us. So a question is here: a carrier signal is frequency modulated, okay, by a message signal of having amplitude AM and frequency FM. So message signal is given like AM cos 2 pi FMT, and this is nothing but MT. Okay. Conducting an experiment with FM equal to 1 kilohertz and increasing AM from 0 volt, it is observed that FM is now given here. FM is like 1 kilohertz. Okay. And it's saying that increasing AM from 0 volt, it is observed that the strength of the carrier frequency component in the spectrum becomes 0 for the first time with AM equal to 2 volt. Find KF. So if you remember from the previous class where we have talked about the Bessel function, see this class, and we have said that the J naught beta, J naught beta is going to be 0 when beta is 2.4, and next is when it is 5.5. So these two values you should remember. So we will use that two value over here, that is J0 beta is equal to 0 when beta is equal to 2.4 for the first time and beta is equal to 5.5 for the second time, correct? So it is saying that the carrier frequency component, which one is carrier frequency component? Strength of carrier frequency component. So what is the general equation of the FM? AC cos 2 pi FC plus NFM into T. And here we have also like AC Jn beta summation n is equal to minus infinity से plus infinity. This is the FM equation. So in this equation, it is saying that the carrier frequency component. What does carrier frequency component correspond to? It's correspond to n equal to 0. If we substitute n equal to 0 in this equation, what we get? That AC J0 beta cos 2 pi FCT. So this is the carrier frequency component, and it is saying that the strength in the spectrum becomes 0 for the first time when AM equal to 2 volt. So that it is indicating that beta is nothing but 2.4. So it is asking what is KF. So what is KF? What is beta? Beta is nothing but delta F upon FM, and delta F is nothing but KF into AM upon FM. So we have beta as 2.4, that is equal to KF multiplied by AM is given as 2 volt. 2 volt upon FM is given as 1 into 10 raised to the power 3 kilowatts. Correct? So KF can be written as like 2.4 into 10 raised to the power 3 upon 2, that is nothing but 1.2 into 10 raised to the power 3. This is what KF is. Okay, so this is what KF is. What would be the the unit of KF? So KF is what? KF is FM upon AM. So it can be kilohertz per volt. Its unit would be kilohertz per volt. Okay. Now KF, once you find KF, it will be fixed. Why it will be fixed? Because it is sensitivity of the modulator. Now second question, it is asked, find the message signal amplitude, that is you have to find AM, for which strength of the carrier frequency component will be 0 for the second time. So it is given that J naught beta will be again 0 when beta is equal to what? 5.5. So you have beta as 5.5, you have KF. So again you can write beta is equal to KF AM upon FM. And in this case now you are having beta, you are having KF, you are having FM, you can find AM easily. Okay. Now let us move to the next question, wherein it is given that CT is this much, MT is this much. Okay. So if we find out what is FC over here, we can say FC is nothing but this is AC cos 2 pi FCT. FCT is what? 10 raised to the power 6, or we can say 100 kilohertz. Okay. Or 1 megahertz. MT is, this is AM cos 2 pi FMT. So FM is what? FM is 2 kilohertz. Okay. CT and MT are used to generate AM with mu 0.7. Find bandwidth and power. So you find bandwidth and you find power. Bandwidth is directly equal to twice of FM, that is 4 kilohertz. And power, you write power is equal to PC 1 plus mu square by 2. Do the calculation and comment in the answer. I will mark who is right, who is wrong. Okay, just comment the correct answer. Similarly, you are between question number B, it is that CT and MT are used to generate FM such that maximum frequency deviation delta F is equal to 4 times the AM bandwidth. Bandwidth already you have found out, that is 4 kilohertz. 4 times the bandwidth. Find the coefficient of the term. This term you have to find the coefficient of this term in the resulting FM. So just now we have seen that the FM signal is given as AC summation n is equal to minus infinity say plus infinity j n beta cos 2 pi fc plus n fm into t. So here this is the coefficient that you have to find out. Okay, and this is like the given term. This is the given term, that is nothing but cos 2 pi into 1014 into 10 raised to the power t into t. Okay, so what is FC? FC is nothing but FC is here we are having FC as 100 into 10 raised to the power 3 hertz. Okay, now trying to bring this component in term of FC plus NFM. So FC plus NFM, that is 100 into 10 raised to the power 3 plus NFM must be equal to 1014 into 10 raised to the power 3. So NFM would be what? It will be 14 into 10 raised to the power 3. And what is FM? FM is given as 1 kilohertz. Sorry, FM is given as 2 kilohertz. So what would be M? What would be M? N will be nothing but 14 into 10 raised to the power 3 upon 2 into 10 raised to the power 3. That gives N is equal to 7. If N is equal to 7, so what would be the coefficient? This would be nothing but AC J7 into beta. Okay. Now you have to find beta, and AC you already know what is it. AC is 5, J7 find out the beta. Beta you can find out. Beta is what? Delta F upon FM. Delta F, it is given. You have find out delta F is nothing but 6 into 10 raised to the power 3, and FM is how much? 2 into 10 raised to the power 3. So beta is nothing but 8. So this term will be equal to what? 5 J7 8. This would be the coefficient. Okay, chalo. Now we'll start with the main topic, that is the receiver. In the receiver, we have already talked that we will be talking about the tuned radio frequency receiver and super heterodyne receiver. These two receiver categories we are going to talk about, and we have already seen the difference between the multiplexer and the multiplier. and sorry, multiplier and the mixer. So mixer, basically it will do either up conversion or it will do the down conversion. We have seen in the previous video or in the previous class, whatever you would like to prefer us. So now also we have understood the FDM technique, that is frequency division multiplexing. Now suppose I am a sender, or let's suppose there are three-person P1, P2 and P3. These are three-person who have some messages to send. And suppose each are using the same technique and the message bandwidth is 10 kilohertz for each person message. 10 kilohertz is their bandwidth. So, but they are what they are having. Now they have to send the message signal, so they can either transmit it through the antenna. The receiver antenna will receive this signal, and then we will have the other receiver block. Or what they can do, they can give it to the transmission equipment, then they can carry it with the optical fiber, and then the receiver transmission equipment will be there. And another, based on the modulation technique, what would be the other component, like demodulation block would be there. So now we are considering that some guided media is there whose bandwidth is like this. And in FDM, we have already seen that each signal is allotted a different carrier frequency range, whose range lies between this F0 and F1. So whose range lies between the bandwidth of the channel. Each is allotted a different carrier frequency. Suppose message 1 is allotted M1T, message 2 is allotted M2T, sorry, F2, and message 3 is allotted F3 carrier frequency. Now, when these are transmitted, the receiver must know at what carrier frequency the message are transmitted. For example, this F3 or the message 3 is transmitted to some another person, say receiver 1, this is for receiver 2, and this is for receiver 3. So the receiver 1, 2, and 3 must exactly know that at what frequency they must tune M, or what frequency they must operate, so that they will get exactly F3 or message M3T. If they tune at F2T, so instead of receiving M2 M3T, they will receive what? They will receive M2T, which would be like the wrong message they would get. Also, this is the one case. First case is what? They need to tune in, or they need to know the exact frequency to which the message is being sent. Another is that suppose this person is R1. Now after some time P2 wants to send a message to R1, and P2 is using the carrier frequency F2. Now there, at this time when P2 want to communicate with R1, whether R1 have to design a new receiver so that it can now accept F2. So in that case, it would be very difficult for each message to be designed a particular receiver to receive different messages from different people. So to solve this problem, International Telecommunication Union ITU has given the range of frequencies. It has given the range of frequencies and the bandwidth of message. Bandwidth of message. Why the range of frequency and bandwidth of message? That can be used in AM and FM modulation. Why they have given? So that you can standardize the design of the receiver. Now you know what range of frequency can be transmitted, so you can predefine. It is already predefined that only this particular range of frequency is allowed in the AM or FM. So accordingly, you can design the AM or FM receiver. Bandwidth of the message, why it is predefined? Because depending upon the bandwidth of the message only, you can use the channel judiciously. Okay? So you can know that if this is 10 number of messages are being transmitted, so at least 10 into bandwidth of one message, this much total capacity of the channel is required. So what are those standard? We will note down. Sometime in the examination, they will give this standard. Sometime you have to remember yourself. So it is better you remember. Like for AM signal, what are the carrier frequency? It is 550 kilohertz to 1050 kilohertz. There is an intermediate frequency IF, which is 455 kilohertz. and the bandwidth is given as bandwidth of the message signal as 10 kilohertz. This is for the case of AM. Similarly, for FM, we have like FM, you must all know that you can tune only 88 megahertz to 108 megahertz, है ना? जितने भी FM स्टेशन है वो इसी फ्रीक्वेंसी के बीच में लाई करते हैं, 92.7, 93.5, whatever FM you are listening currently, it lies between this message frequency, this frequency range only. So in this case, what is an IF? So IF here is like 1007 megahertz. This is also in megahertz. In AM we have kilohertz. In FM we are having megahertz. Okay. So what is the bandwidth? Bandwidth is nothing but 200 kilohertz. So this is the standard being defined by the International Telecommunication Union. Now for any receiver, suppose I am going to design a receiver. For any receiver, what are the parameters that made a receiver a good receiver? Number one is the selectivity, and number two is the rejection, or we can say that the proper rejection. Proper rejection. What do you mean by selectivity? For example, a receiver is designed or tuned to receive particular frequency f1. So it should allow the f1 to be received completely with no attenuation. With no attenuation. Proper rejection, it should reject all other frequency which is not meant to be received. Why? Because suppose if you are expecting f1 to be received and you are also getting f1 plus delta f. So in that case, these two frequencies would again create what? Noise, and may distort the signal. So a good receiver is that which has proper selection and proper rejection. So we say that the quality, or we can say that the quality factor of the receiver is like given as frequency to which it is tuned upon bandwidth. Okay, frequency to which it is tuned upon bandwidth. Now just try to understand that there are two receiver. One is having like this. This is the central frequency. Another is having characteristic like this. And this is the desired frequency f0, which is to be received. So here the bandwidth is less and here the bandwidth is more. So which receiver is good? This receiver or this receiver? Obviously this receiver is good. Why? Because it is allowing only a minimum amount of unwanted frequency, that too with the reduced amplitude, and it is allowing the desired frequency, the maximum gain or the maximum amplitude. So this receiver is the high selectivity and high rejection. Okay. But on the other hand, this receiver, this frequency was to be received. Apart from that, it is also allowing a significant amplitude to the other frequencies. Nevertheless, means not only that, it is also allowing a wider range of frequencies to be received. So that means bandwidth is, it is allowing larger bandwidth of the signal to be received. So it has a poor rejection and selection. Okay. So from these two diagrams, we have understood that bandwidth should be ideally as low as possible. So if this bandwidth is very small, then we can assume that quality factor is very high, and this is desired. The quality factor of any receiver is high is desired. Okay. But this is like the design constraint. This is like what? Design constraint. Once you design a receiver, quality factor or Q is fixed. Okay. And maximum you can have like 200. Maximum Q can be like 200. It is the maximum Q that you can achieve. Or if you design it more precisely, more accurately, then maybe you can get 250, but it is in the range 200 to 250 only. So if we say that, like suppose, for example, I'll say, now let us first have an idea of what are the basic of a receiver. This is the antenna which is going to receive. Then here we have a radio frequency amplifier. Then here we have a demodulator. Then here we have an audio frequency amplifier. And then we have a power amplifier. And then we have the output source or speaker. Okay. This is the basic block of a receiver. Okay. So what is the radio frequency amplifier? Radio frequency means high frequency. It is high frequency amplifier means जो जो भी आपका मैसेज आ रहा है जो कि कैरियर फ्रीक्वेंसी भी भेजा गया, तो कैरियर फ्रीक्वेंसी जनरली मेगाहर्ट्ज के रेंज में होता है, तो उस हाई फ्रीक्वेंसी को जो एम्पलीफाई करेगा पहले, फिर भी हैव अ डीमॉड्यूलेटर। डीमॉड्यूलेट करने के बाद आपको क्या मिलता है? एमटी। एमटी क्या होता है? लो फ्रीक्वेंसी, यानी कि किलोहर्ट्ज के रेंज में होता है। उस लो फ्रीक्वेंसी के लिए वी हैव एन ऑडियो एम्पलीफायर। तो कहीं भी अगर आपको एग्जाम में दिख जाए कि ऑडियो एम्पलीफायर, दैट मीन्स इट इज अ लो फ्रीक्वेंसी एम्पलीफायर। Then we have a power amplifier to boost the power of the signal so that it can be physically converted into audio signal. Correct? So this is the basic of a receiver. Now we will be talking about, like suppose a receiver. Suppose if a receiver RX is designed that okay, we are going to receive suppose a carrier frequency of 100 kilohertz. Okay, so we have to design a receiver for receiving this carrier frequency 100 kilohertz, and bandwidth is given as 10 kilohertz. Bandwidth of the message signal that should be allowed is 10 kilohertz. Like this is the message signal. This is 10 kilohertz. It's bandwidth of the message signal. But this is like suppose if like what is the frequency of 1.5 kilohertz? This is the voice signal. So in that range only, suppose this is 1 kilohertz, and this is like say 10 kilohertz. So this is the MT. But when you have to modulate it, obviously you have to shift it to the higher frequency, say FC. So if this is FC is like 1 kilohertz, 1 megahertz. So accordingly, this frequency and this frequency will change. But overall, the bandwidth of the message will remain 10 kilohertz. So if this is the message signal MT, whose bandwidth is 10 kilohertz, and it has to be tuned to this carrier frequency. This carrier frequency, it has to be tuned FC, that is 1 megahertz or 100 kilohertz, and should allow the message bandwidth of 10 kilohertz. So what would be the quality factor required? The quality factor would be like omega upon bandwidth. That is nothing but 100. This you design it and you fix it. Okay. Now, suppose it is said that this receiver is used to receive a signal of like 600 kilohertz. If this is the carrier frequency, or we can say 0.6 megahertz, if this is the carrier frequency, now once you design the receiver, its quality is fixed. So quality is Q is 100, and now you have to receive this 600 kilohertz. So what would be the bandwidth that it will allow with this quality factor? So you can write quality factor is equal to omega naught upon bandwidth. Okay. So bandwidth could be what? 600 into 10 raised to the power 3 upon 100. That is 6 kilohertz. But what was the bandwidth of the original message signal? It was only 10 kilohertz. That means out of 10 kilohertz, it is only allowing 6 kilohertz of bandwidth, and remaining 4 kilohertz it's attenuated. That means only this range of frequency will be allowed. This range of frequencies will be attenuated. Why? Because our receiver was designed to optimally work only at 100 kilohertz of frequency, carrier frequency. If FC is this, then only we can like effectively get back the entire message signal. However, if we change this FC to like 600 kilohertz, we are seeing that almost 4 kilohertz, what almost exactly 4 kilohertz of the message bandwidth are lost. So now in such type, there is a limitation that we are fixing our FC. Okay, we are fixing our FC. So this limitation we will try to overcome in super heterodyne receiver. So try to like understand what could be the possible solution. Just try to understand what could be the possible solution. Like obviously it is fixed now that if you are using a tuned amplifier or any amplifier whose frequency will be like 1 upon 2 pi root over LC, and once you design L and C, obviously omega naught that it will work will be fixed only, that there is no doubt in it. So what, how you can make such receiver to receive like any number of frequency or any message being transmitted over any frequency within the range, it will be able to receive. How you can do that? See, what we can do, we have received now, we have means already done the mixer. So what could be done? Like, see, you have to understand this, understand this like very carefully. Is the demodulator, okay? And what we say that, okay, demodulator, before demodulator, this is a radio frequency, and if in demodulator we give it, if we give it a frequency other than that frequency, so what MT we recover is like some part of the bandwidth is lost. This is what we have seen above. So in order to like, if this is the ratio of radio frequency amplifier, or we can say the tuned amplifier, if this is the case, so if we are allowing this, if we are designing this for a particular frequency FC, ठीक है, अगर एक frequency FC के लिए हम इसको डिजाइन कर रहे हैं, तो हमको इंश्योर करना पड़ेगा कि यहाँ पर हम कुछ ऐसा ब्लॉक लगाएं, इससे पहले कुछ ऐसा ब्लॉक लगाएं जिसके वजह से जो भी फ्रीक्वेंसी यहाँ पर आए, ठीक है, जो भी फ्रीक्वेंसी यहाँ से रिसीव करे, उससे कोई भी फर्क ना पड़े, बट यहाँ पर जो भी फ्रीक्वेंसी आए वो वही फ्रीक्वेंसी हो जिसके लिए ये रेडियो फ्रीक्वेंसी एम्पलीफायर या ट्यून्ड एम्पलीफायर को डिजाइन किया गया है। ठीक है, अगर हम ये इंश्योर कर दें तब हमारा प्रॉब्लम सॉल्व हो जाएगा, क्योंकि ये अभी हमने पहले देखा कि अगर ये एफ सी इज इक्वल टू 100 kHz के लिए डिजाइन किया गया था तो ये इफेक्टिवली काम कर रहा था, लेकिन जहां एफ सी की वैल्यू हमने 600 कर दिया, 1000 kHz के लिए काम कर रहा था, 600 kHz कर दिया, तो फिर हमने देखा कि बैंडविड्थ का लॉस हो रहा है, एटेन्यूएशन हो रही है सिग्नल में। तो अगर हम ये इंश्योर करें कि रिस्पेक्टिव ऑफ व्हाट इज रिसीव्ड ओवर हियर, यहाँ पर जो भी फ्रीक्वेंसी आए वो वही कैरियर फ्रीक्वेंसी होनी चाहिए फॉर विच दिस इज डिजाइन। ठीक है, तो इन सुपर हेटेरोडाइन रिसीवर वी से दिस एज व्हाट, वी से दिट एज immediate frequency, intermediate frequency, and this amplifier will be now termed as intermediate frequency amplifier. This is called intermediate frequency amplifier, और we will ensure कि यहाँ पर जो फ्रीक्वेंसी आएगी वो क्या आएगी, इंटरमीडिएट फ्रीक्वेंसी। इन केस ऑफ एम व्हाट इज इट इज 455 किलोहर्ट्ज, ये फ्रीक्वेंसी आएगी। ठीक है, तो अब कैसे इंश्योर करेंगे वो हम देखेंगे थोड़ी देर में। तो अगर हम ये इंश्योर कर दे कि भाई ये इंटरमीडिएट फ्रीक्वेंसी एम्पलीफायर के पास जो फ्रीक्वेंसी आएगी वो ऑलवेज फिक्स होगी 455 किलोहर्ट्ज के लिए, तो इस फ्रीक्वेंसी के लिए वी कैन इंश्योर मैक्सिमम क्यू, और जो है वो एग्जैक्टली बैंडविड्थ जो है हमें जो रिक्वायरमेंट होगा वो हम अचीव कर सकते हैं। सो इन सुपर हेटेरोडाइन रिसीवर दिस को हम बोलते हैं ट्यून्ड एम्पलीफायर, और this is also known as the intermediate frequency amplifier. So if we are fixing the frequency, the problem is solved. How we will do that? See, here we have an where this is a multiplier or mixer. This is a mixer, okay? और यहाँ पर हम एक लोकल ऑसिलेटर लेते हैं। अब हम जो भी हमारी फ्रीक्वेंसी आ रही है यहाँ से एफ आर फ्रीक्वेंसी, हम इंश्योर करते हैं कि लोकल ऑसिलेटर एफ एल वो फ्रीक्वेंसी जनरेट करे जहां से इन दोनों का जो डिफरेंस है एफ एल माइनस एफ आर वो आई एफ के बराबर हो। वो तो हम आराम से कर सकते हैं ना, देर इज नो बिग डील इन इट। वी ऑलरेडी नो कि जो मिक्सर होगा व्हाट इट विल डू, इट विल आइदर डू अप कन्वर्जन और आइदर इट कैन डू डाउन कन्वर्जन। तो अगर अप डाउन कन्वर्जन करेगा, और ये हम प्रेफर करते हैं कि जब हम सुपर हेटेरोडाइन रिसीवर करते हैं, रिसीवर ले रहे हैं, तो उसके अंदर जो मिक्सर है वो डाउन कन्वर्जन ही करे, हम इसके लिए इसको फिक्स करते हैं डाउन कन्वर्जन, ऑलवेज ऑलवेज डाउन कन्वर्जन। वाई, वी विल सी द रीजन इन अ लिटिल वाइट। डाउन कन्वर्जन, ठीक है, डाउन कन्वर्जन के लिए हम डिजाइन करते हैं, वाई वी विल सी द रीजन इन अ लिटिल वाइल। अभी समझ लो डाउन कन्वर्जन कर रहा है, और डाउन कन्वर्जन के लिए क्या होना चाहिए, एफ एल शुड बी ग्रेटर देन एफ आर, दिस शुड बी द कन्वर्जन, एफ एल शुड बी ग्रेटर देन एफ आर, और इन दोनों का डिफरेंस एफ एल और एफ आर का डिफरेंस मस्ट बी नथिंग बट इक्वल टू आई एफ। फॉर एग्जाम्पल अब देख लो, अगर आपने पहले आपका मान लो कि फ्रीक्वेंसी आपकी आ रही थी 1000 किलोहर्ट्ज, और आपको जो आपका ट्यून्ड एम्पलीफायर है, यानी कि इंटरमीडिएट फ्रीक्वेंसी एम्पलीफायर, उसको आपने डिजाइन किया हुआ 455 किलोहर्ट्ज के लिए। तो ऑब्वियसली यू कैन choose the local oscillator frequency as 1455 kilohertz. So if the oscillator will produce 1455 kilohertz and this is given to the mixer, so this will produce nothing but 1455 minus 1000, that is 455. नाउ अगर आप इसको 600 किलोहर्ट्ज पे का फ्रीक्वेंसी आपको रिसीव करना है, सो यू मॉडिफाई इट अकॉर्डिंगली। 1055 पे आप इसको लोकल ऑसिलेटर की फ्रीक्वेंसी चेंज कर दो 1055 पे। तो दिस तो यू कैन डू इट, दिस यू कैन डू इट। सो व्हेन यू आर मिक्सिंग विद दिस फ्रीक्वेंसी विद 600 फ्रीक्वेंसी, you are again fixing the intermediate frequency as 455. So whatever is the frequency you are receiving, irrespective of that, you change the local oscillator frequency, mix it with the incoming frequency, so that the intermediate frequency that you get, FL minus FR, is nothing but 455 kilohertz, for which this is designed. So if this is done, that means now we can have a single receiver which can be now made available for any range of frequency to receive any message signal which is transmitted for any carrier frequency. If that is okay, so if this is okay, so you have to write down this formula, note down this formula, that intermediate FL, like FL minus FS, this is the message signal, ठीक है, must be equal to IF, intermediate frequency, and this is down conversion, we always do the down conversion, ठीक है। This is one of the formula that we have understood. Now write two more formula. Image rejection ratio, that is alpha. Okay, before that let us understand what is image frequency. Now यहां तक अगर हम लोग समझ गए हैं तो यहां पर एक और प्रॉब्लम होगा, ठीक है। क्या प्रॉब्लम होगा उसको अभी हम लोग यहाँ पर सोचने की कोशिश करेंगे। सपोज ये हमारा एक एफएस है, ठीक है, और ये हमारा मान लो 1000 है, ठीक है, और इसके लिए हमने यहाँ पर मिक्सर लगा दिया है और यहाँ पर एक ऑसिलेटर है जो कि हमें पता है कि क्या फ्रीक्वेंसी प्रोड्यूस करेगा, 1455। जिसका जब ये प्रोड्यूस करेगा तो ये मिक्सर करके यहाँ पर जो फ्रीक्वेंसी आएगी वो 455 किलोहर्ट्ज की होगी। और इसके बाद हमारा सिस्टम डिजाइन किया गया है वर्क करने के लिए। ओके, दिस इज गुड। सो दिस इज ऑल्सो डिजायर्ड, यही हमको डिजायर्ड करना है। और मिक्सर ऑलवेज क्या करता है, डाउन कन्वर्ट करता है। लेकिन ऐसा भी केस होगा, यहाँ पर मैंने क्या बोला कि यहाँ पर जो आपकी फ्रीक्वेंसी आती है दैट इज बेसिकली डिफरेंस ऑफ दिस टू। तो यू सी देयर आर टू केसेस। अगर हमारा सिग्नल फॉर वन ऑसिलेटर की यह फ्रीक्वेंसी हमने फिक्स कर दी कि भाई यही फ्रीक्वेंसी हम प्रोड्यूस करेंगे ताकि ये एफ एस पे ये आई एफ जनरेट हो। सो वो आपको यहां से पता भी चल रहा है कि दिस फ्रीक्वेंसी माइनस 1000 इज नथिंग बट 455। लेकिन एक और यहाँ पर एक और सिग्नल होगा जो कि अनइंटेंडेड सिग्नल होगा, जिसको आप इंटेंड नहीं कर रहे हो। मान लो अगर वो होगा 1910 1910, अगर ये एक ऐसा इस फ्रीक्वेंसी पे there is a one signal, so which is unintended, but if it comes into the mixer again, इसको भी ये 455 पे रिड्यूस करेगा। कैसे, देखो, एक तो ये केस हो गया ना जहां पर हम ये कर रहे हैं कि एफ एल माइनस एफ एस। दूसरा ये भी तो केस हो सकता है डिफरेंस के लिए, डिफरेंस एफ एल एफ एस माइनस एफ एल भी हो सकता है जो 455 प्रोड्यूस होगा, जो कि इस केस में हो रहा है। देखो 1910 माइनस 1455, this is nothing but 455। So this case is also producing what? Same intermediate frequency 455. You understand what I mean to say? That this is the desired signal. We want to receive this. For this, we have tuned this amplifier local oscillator to generate 1455. This is given to mixer, and as intended, it is down converting it to 455. And this is further given to demodulator and all. But unintentionally there is one another frequency component which is at 1910. When this comes to the mixer, with the same oscillator frequency 1455, the difference produces also 455, also 455. So this message signal also passes with the tuned amplifier, as it also means down converted to 455, and then it is also demodulator. So you were expecting only M1T, but you are getting messages at two different M2T and M1 to two different messages you are getting. So this is again the problem. So the solution is very simple if you can think. And this frequency is called nothing but the image station, FSI. This is the actual signal which is to be received, and this is the image station signal which will also produce the same intermediate frequency. Now, if you have understood the FSI and you have understood the FS, so now you can write image rejection ratio is nothing but gain offered to FSI upon gain offered to, gain offered to FS upon gain offered to FSI. Image rejection ratio is gain offered to Fs by gain offered to frequency component FSI. ठीक है? And this is nothing but alpha. Remember this, direct question can come. Image rejection ratio. Alpha can be also given as root over 1 plus p square and q square, where q square is the quality factor of the receiver, and p can be written as FSI image frequency upon desired frequency minus desired frequency upon image frequency FSI. Okay, this is p. Find p from here and multiply it with q square, and you can find alpha from here also. Also, if p square and q square is much greater than 1, so alpha can be equal to pq. Correct? Now, I have told that in the receiver we already prefer down conversion. Down conversion. Why we prefer down conversion? For before that, we see f is given as 1 upon 2 pi root over LC, or we can say f square can be given as 1 upon 4 pi square LC. Now, if we are like designing it for a minimum frequency, f minimum, so C capacitance will be maximum, it is inversely proportional. So can we say that f low whole square या local oscillator का minimum frequency whole square is inversely proportional to C maximum? From here we can derive the formula FL max upon FL min is whole square is nothing but C max upon C min. This is another formula that you have to understand. So what is FL max, FL min? FL is the maximum oscillator frequency that the oscillator will produce and give it to the mixer. And FL min is the minimum oscillator frequency that the oscillator will produce and give it to the mixer. Okay. So this is C max upon C min. Now C max upon C min is lower in down conversion. Just remember this. You can do this practically also. And C max upon C min is higher in up conversion. So if C max upon C min is higher, that means higher large resources are required. So we try to keep C max upon C min as small as possible, and therefore down conversion is preferred. For example, suppose we say that for AM, what are the different range of carrier frequency? That is, we have just seen as 550 to 1050 kilohertz. Okay, and the intermediate frequency is 455. So for this, for down conversion, what we require? FL minus FS should be equal to 455, or local oscillator frequency is nothing but 455 plus F signal. So for this, what FL can be? This will be nothing but 50. You add this 455, 1005. Okay, and for this, it would be like 5051. This is the like minimum, and this would be like maximum 1505. Okay, now for up conversion, Fs minus Fl will be equal to 455, or Fl will be like Fs minus 455, So in this case, it would be like what? 550 minus 455, that will be equal to 10 minus 5, 495. Similarly for this, 1050 minus 455. So what you will get? 455, 5, 9, 4, 495. This is what you are getting. So this is like FL minimum, and this is what FL maximum. So if you find the ratio of FL max upon FL minimum, in this case, that is in the up conversion case, it is nothing but 495 upon 95. And if you find for this case, that is down conversion case, which is nothing but 1505 upon 1005. So you see, here it is much, much greater than this case. Okay. So this is what? This is C max upon C min. So C max upon C min, again, if you have used, you have to do square also. F max upon FL max upon FL min का whole square is C max upon C min. तो इसका स्क्वायर करोगे तो दिस डिफरेंस लाइक हाउ मच इट विल कम 95, 4 ऑलमोस्ट 9 4 जा 36, 9 5 जा 45, ऑलमोस्ट 4 और 5 के बीच में आएगा, स्क्वायर करोगे तो 16 आएगा, और ये ऑलमोस्ट 1.5 के पास में आएगा, स्क्वायर करोगे तो 2.25 आएगा। तो एक जगह सी मैक्स डाउन कन्वर्जन में सी मैक्स अपॉन सी इन का रेशियो कितना आ रहा है? 2.25, और अप कन्वर्जन में इसका रेशियो 16 आ रहा है। सो दिस में ज्यादा रिसोर्स यूज होगा, है ना, इंफ्रास्ट्रक्चर लगेगा, ज्यादा बड़ा बनेगा, ऑसिलेटर भी बड़ा बनाना पड़ेगा, और इस केस में कम इंफ्रास्ट्रक्चर लगेगा। सो दैट इज वाई जो है हम क्या यूज करते हैं, सी मैक्स अपॉन सी मिन को स्मॉल रखने के लिए डाउन कन्वर्जन प्रेफर करते हैं। ओके, आई होप यू अंडरस्टूड, यू वुड हैव अंडरस्टूड दिस। चलो, तो अभी जो प्रॉब्लम ऊपर में था इमेज स्टेशन का, उसको हम लोग कैसे दूर करेंगे? इमेज स्टेशन का जो प्रॉब्लम है उसको हम लोग कैसे दूर करेंगे? इमेज स्टेशन कहाँ पर आ रहा है? इमेज स्टेशन आपका यहीं यहीं से आ रहा है, इमेज स्टेशन यहीं से आ रहा है इमेज स्टेशन, और ये मिक्सर के पास जा रहा है। तो हमको मिक्सर से पहले कुछ ऐसा कंपोनेंट लगाना होगा जो कि मिक्सर पे ओनली एफएस को पास करे और एफएसआई को पास ना करे। यही तो हमारा मेन फंक्शन होगा। मतलब कि देखो, यहाँ पर क्या आ रहा था, यहाँ पर आ रहा था एफएस, और जो कि डिजायर्ड स्टेशन था, उसकी फ्रीक्वेंसी थी 1000 किलोहर्ट्ज। वो मिक्सर में हम अलाउ कर रहे थे, और ऑसिलेटर को उसी के हिसाब से हमने सेट किया था 1455 जनरेट करने के लिए, जहां से हमारा डाउन कन्वर्ट करके 455 जनरेट हो रहा था। लेकिन अनइंटेंशनली एक इमेजिनरी या एक इमेज स्टेशन आ गया, जो कि ऑसिलेटर से मिल करके मिक्सर से डाउन कन्वर्ट हो करके या अप कन्वर्ट हो करके सेम ही फ्रीक्वेंसी पे आ रहा है। ठीक है, तो बेसिकली हमको इसको ब्लॉक करना है, इसको अलाउ करना है। तो इससे पहले आप क्या लगा सकते हो, एक ट्यून एम्पलीफायर और एक लगा दो, और जिसकी कट ऑफ फ्रीक्वेंसी आप क्या कर दो, यहाँ पर आपने फ्रीक्वेंसी क्या सेट कर दिया, 455, यहाँ पर आप इसकी फ्रीक्वेंसी सेट कर दो एफएस पे। तो एफएस तो आप डिजाइन कर सकते हो 1/2 पाई रूट ओवर एल सी, और सी को आप वेरिएबल रख दो, वेरिएबल कैपेसिटर रख दो। तो सी को चेंज करके आप सेट कर लो एफएस पे। तो ऑब्वियस सी बात है कि एफएसआई यहाँ से आगे नहीं जाएगा, एफएससी आगे जाएगा। तो हियर वी कैन यूज वन ट्यून्ड एम्पलीफायर, वी कैन यूज वन ट्यून्ड एम्पलीफायर। ओके, डन। तो अभी देखो, एक तो हमने ये पढ़ा, एक फॉर्मूला हमने ये पढ़ा, एक फॉर्मूला हमने ये पढ़ा अल्फा का, एक ये पढ़ा एफ एल मैक्स अपॉन एफ एल मेन, और ये देखा हमने क्यों डाउन कन्वर्जन की रिक्वायर्ड है, वो अब आपको याद भी रहेगा। और ये इमेज रिजेक्शन रेशियो का गेन के टर्म में हमने देखा, और एक ये देखा। ठीक है, अगर इमेज फ्रीक्वेंसी वाला केस में हम देखेंगे, तो इमेज फ्रीक्वेंसी के टर्म पे नॉर्मली क्या होता है, एफ एल माइनस एफ एस इज इक्वल टू आई एफ होता है, डाउन कन्वर्ट करते हैं, और यही रिक्वायर्ड होता है, एफ एल ग्रेटर देन एफ एस। लेकिन जब इमेज स्टेशन आएगा तो उस समय क्या होगा, एफ एस आई, ठीक है, माइनस एफ एल विल बी इक्वल टू आई एफ, यही जनरेट होगा। तो इस केस में हम देखेंगे कि एफ एस आई क्या होगा, एफ एस आई इज नथिंग बट एफ एल प्लस आई एफ, और एफ एल यहां से क्या निकलेगा, एफ एल फ्रॉम हेयर इज नथिंग बट आई एफ प्लस एफ एस। तो एफ एल को रिप्लेस कर देंगे यहाँ पर आई एफ प्लस एफ एस से, तो हमारा एफ एस आई क्या आ जाएगा, एफ एस आई इज नथिंग बट एफ एस प्लस ट्वाइस ऑफ आई एफ। So this is another important formula that you should remember. Okay, this is another formula that you should remember. This is one formula that you should remember. This will be helpful in solving questions from receiver. So this is image station, and we can easily get rid of this by using one tune amplifier. Correct? Now there are two more things that is to be understood, and then we will be finishing off with this receiver topic. See, what we are going to talk about now is fidelity of a receiver. Fidelity का मतलब होता है faithfulness. That means ability of the receiver to reproduce all positive frequency component of transmitted MT. ठीक है, all frequency component of transmitted MT. ठीक है, that is we have understood. Now see, signal to noise ratio, there is a one term known as signal to noise. Signal to noise. So signal to noise ratio for low frequency. लो फ्रीक्वेंसी के लिए क्या होता है? इन लो फ्रीक्वेंसी, देखो जैसे फ्रीक्वेंसी हाई होगी नॉइस का इम्पैक्ट हाई होगा। ये तो आपने देखा भी है ना, जब अपने एक्सपीरियंस क्या होगा, जब आप बहुत जोर से चिल्लाते हो तो आवाज कम समझ में आती है और नॉइज उसमें ज्यादा इम्पैक्ट करता है। तो हाई फ्रीक्वेंसी पे नॉइस का इम्पैक्ट ज्यादा होता है। तो अगर ये बात हमें समझ में आ गई कि हाई फ्रीक्वेंसी पे नॉइस का इम्पैक्ट ज्यादा होता है, तो अगर लो फ्रीक्वेंसी मैसेज, अब एमटी है, एमटी में तो क्या है, हमारे पास सारे टाइप्स के फ्रीक्वेंसी होंगे, कुछ लो होंगे कुछ हाई होंगे, है ना। कुछ हाई फ्रीक्वेंसी कंपोनेंट होंगे, कुछ लो फ्रीक्वेंसी कंपोनेंट होंगे। तो अगर लो फ्रीक्वेंसी कंपोनेंट है तो वहां पर अगर चैनल का नॉइस हम मान लें कि जिस चैनल से भेजा गया उसका नॉइस कांस्टेंट है, जो कि हम एनालिसिस करेंगे बाद में, तो नॉइज अगर कांस्टेंट है तो सिग्नल, तो नॉइस लो फ्रीक्वेंसी पे इसका इफेक्ट कम होगा, तो सिग्नल टू नॉइज रेशियो हाई होगा। अगर हम हाई फ्रीक्वेंसी पे बात करें तो हाई फ्रीक्वेंसी पे सिग्नल टू नॉइज रेशियो पे नॉइस का इम्पैक्ट ज्यादा होगा और ओवरऑल सिग्नल टू नॉइज रेशियो क्या हो जाएगा, कम हो जाएगा। तो जब सिग्नल ओवरऑल सिग्नल टू नॉइज रेशियो कम हो जाएगा तो जो हाई फ्रीक्वेंसी कंपोनेंट है उसको हम डिसाइफर नहीं कर पाएंगे मैसेज को। क्यों? क्योंकि उसमें नॉइज का इम्पैक्ट ज्यादा है। ये बात समझ में आ गई? नॉइज का इम्पैक्ट ज्यादा है, मतलब कि ये जो लो फ्रीक्वेंसी कंपोनेंट है इसको तो हम इजिली कर लेंगे, रिसीव करके डिमॉड्यूलेट कर लेंगे, लेकिन जैसे ही हायर फ्रीक्वेंसी की तरफ जाएंगे तो क्योंकि नॉइज का इम्पैक्ट हाई फ्रीक्वेंसी पे ज्यादा हो जाएगा, इस वजह से हम क्या कर पाएंगे, इसको सही से डिसाइफर नहीं कर पाएंगे। तो इसके लिए क्या सोल्यूशन है? इसके लिए हमारे पास दो सोल्यूशन है। पहला कि नॉइज का इम्पैक्ट कम कर दो, या फिर सिग्नल का इम्पैक्ट बढ़ा दो, सिग्नल के पावर बढ़ा दो। किसके लिए? और हाई फ्रीक्वेंसी कंपोनेंट के लिए। तो नॉइज को तो हम कम नहीं कर पाएंगे क्योंकि नॉइज रैंडम नॉइज होता है और वो चैनल पर डिपेंड करता है, तो दिस वी कैन नॉट डू। सो व्हाट वी कैन डू, वी कैन ट्राई टू इंक्रीज दी और बूस्ट दी हाई फ्रीक्वेंसी सिग्नल्स। सो दिस इज व्हाट नोन एज प्री एम्फेसिस। दिस इज व्हाट नोन एज प्री एम्फेसिस। वन लाइनर क्वेश्चन प्री एम्फेसिस से आ सकता है कि व्हाट इज दिस। सो प्री एम्फेसिस क्या करते हैं हम, कि जब भी हमारे पास एमटी होता है उस एमटी के हाई फ्रीक्वेंसीज कंपोनेंट को पहले हम बूस्ट कर देते हैं मॉड्यूलेशन से पहले। बूस्ट बिफोर मॉड्यूलेशन, बिफोर मॉड्यूलेशन हम बूस्ट कर देते हैं। तो लो फ्रीक्वेंसी का तो कोई मसला नहीं है भाई, लो फ्रीक्वेंसी का सिग्नल टू नॉइज रेशियो वैसे ही हाई है। हाई फ्रीक्वेंसी में हम सिग्नल की पावर को बढ़ा देते हैं ताकि नॉइज का इम्पैक्ट ज्यादा होने के बाद भी सिग्नल टू नॉइज रेशियो सफिशिएंटली हाई हो जहां से मैसेज डिसाइफर कर पाए। इसी को बोलते हैं प्री एम्फेसिस। और इसका जब उल्टा करेंगे तो उसको बोलेंगे डी एम्फेसिस। डी एम्फेसिस कहाँ करेंगे? रिसीवर में करेंगे। रिसीवर में कर देंगे, जब मैसेज को डीमॉड्यूलेट कर देंगे, मॉड्यूलेट कर देंगे, तो हमें पता है कि डीमॉड्यूलेशन के प्री एम्फेसिस किया गया था, मतलब कि हाई फ्रीक्वेंसी कंपोनेंट की एम्पलीट्यूड को हमने बूस्ट किया था। तो यहाँ पर हम क्या करेंगे, उसको वापस बैक टू नॉर्मल करेंगे। तो दिस इज कॉल्ड प्री एम्फेसिस एंड डी एम्फेसिस। ठीक है, सो दिस इज ऑल विद द रिसीवर गाइस। आई होप आपको ये चीज समझ में आई होगी पूरा, डी प्री एम्फेसिस डी एम्फेसिस क्या होता है, सिग्नल टू नॉइज रेशियो एंड ऑल थिंग जो भी हम रिसीवर में बात किए हैं। In the next class, we will start with the digital communication and we will try to solve some question on based on this receiver so that we will get more clarity. And why I'm not solving this question now, because you people will you'll try to recall all this thing, learn all the formulas. So in the next class, you will be also able to solve with me. So okay, this is the end of the class. So we'll meet in the next class. Thank you.